Okay, it's 6 o'clock and start. So in our last class, we discussed designing of concrete pavement. So today we'll discuss flexible pavement design as per the latest code, which is IC 37 2018. So in flexible pavement design, you should know these things, that whenever you are designing new pavement, those kind of projects are called greenfield projects. Greenfield projects. And whenever you are uh, upgrading some roads or any kind of innovation works, in that kind of works, the codes that has to be referred will be different. So in greenfield project, that means you are designing the road for the first time with with everything from zero. In those kind of projects, if the design traffic is less than 2 MSA, then you have to design it as per IRC SP 72. SP means special publication, you already know. So that means the traffic is less. So generally for rural roads, this code is used to design the pavement. But in most of the cases, if generally the traffic will be more than 2 MSA, and I hope you already know what is MSA, million standard actions. That means for the design period can be 10 years, can be 15 years. So for in that 10-15 years of design period, if the total traffic is more than 2 MSA, then you have to use this IRC 37, which we are going to discuss in details, because in most of the cases the design traffic will be more than 2 MSA. Okay, but in case of overlaying of all pavement, you must have noticed that when the inflexible pavements, they generally don't last for more than 6 years, right? Of course they are designed for 15 years, but they need rehabilitation. Okay, rehabilitation in the sense the layer has to be removed and a new layer will be placed. Okay, that is called overlaying. So for overlaying, the methods or the guidelines that are followed are given here. So IRC 81, which uses Benkelman beam. So this method is used for secondary and tertiary roads, that means state highways, major district roads and rural roads. And for primary roads such as NH or expressway, we have to use IRC 115. So here, falling with deflectometer, this instrument is used, and here this Benkelman beam deflection technique is used. Okay, so today we will be discussing IRC 37 in details. Alright, so you already know all the layers in flexible pavement. Still, let's quickly recap. The first layer will be called wearing course or surface course, because it is always on the surface, right? Then the second layer is binder course, and both these two layers will be bituminous in nature. That means they will have the binder as bitumen. So bitumen is the binding material. Okay, then you have base course and sub base course. So both will be made of granular materials, base and sub base. Okay, sub base will have inferior materials, means the aggregate size will be higher compared to base course. Similarly, in binder course also, the aggregate size will be higher, the bitumen content will be less. But ultimately, for analysis, if you remember, we combined these two layers, both the bituminous layers, and we considered as only single layer. Okay, and similarly for granular layers also, we considered this base and subbase together and considered as one granular layer only. And below that we have subgrade. So compacted subgrade 150 mm, then nacelle subgrade, that means the existing embedment. So the thickness is really not taken into account, as you have seen in the analysis lectures, like whether it is one layer theory or two layer theory, it is always considered infinitely deep. That means it is half space, semi-infinite, right? So uh, when we say designing a flexible pavement, that means two things. First, we need to like identify what are the materials to be used in the layers, okay, and what should be the thickness of the different layers, okay, to what, to sustain the traffic load in its design life. Suppose the design life is 15 years. That means in 15 years of life service period, the pavement has to sustain all the traffic load or the vehicular load coming to the road without failing. Okay, and for that we need to find out the material properties as well as its, you know, we will assume the material properties because materials will be already with you, so you know what kind of materials you are going to use. So you don't have, generally you don't have much option of choosing different materials. So uh, you have to decide which materials you are using and what should be the thickness of the materials that you need to design and figure it out. Okay, so in ISA 37, okay, there are different, you know, design choices given. Like till now we have discussed only this kind of, you know, pavement structure where the first layer is wearing binder, base, sub base, like that. But with advancement of software and also advancement in vehicular loads, this kind of structure can be enhanced. Enhanced in the sense, suppose if you use this kind of structure, these base course and sub base course, which use granular materials, their thickness will be very high if the vehicular load is high. That means for expressways and all, if we consider multi-axle trucks and all those things, then the load coming into this pavement will be very high, and in order to resist it with normal granular materials in base and sub base course, also the thickness will be very high. Okay, when the thickness goes up, the main problem is the material requirement, because you know the material requirement, uh, like there is a scarcity of natural aggregates, right? So when we talk about sustainability, we need to think about the future as well, right? That if we simply can reduce the thickness by using alternative materials, then why are we wasting our natural aggregates, such valuable aggregates, by using this kind of simple structure? So IRC 37 has suggested that we can use different structures as well. So what are these 6 different structures that are allowed in IRC 37? First one is the simple that we have learned, that means bituminous layers, wearing course, binder course, granular base, granular surface, and subgrade. Okay, it's as simple as that. So like we will mainly discuss this because that is the most common structure, pavement structure, in almost 75% or 80% of the flexible pavement in India. But we'll also learn the different, you know, variations, how to like design this kind of pavement structure as well. So these variations are, so you see, instead of granular, what is this CTB? Any idea? Can anyone guess what can be this CTB? We have learned geotechnical, soil mechanics. So any guess what can be CTB? In order to improve the quality of, why are we first like um, introducing this kind of options? This is a traditional one, right? So why are you introducing this kind of design catalogs, because we need to make the layers thinner, and the layers can be made thinner only if these layers will be stiffer, right? Only if these layers are stiffer, then only we can afford to have thinner layers. So in order to make these granular materials stiff, what can we do? Any suggestion? How do you improve the engineering properties of granular materials? Come on, at least anyone? No one? Similarly, how do you improve the engineering properties of granular materials? Say soil. How do you improve the properties of soil? No? You use stabilizer, right? You stabilize. So what kind of stabilization can be done? Lime stabilization, then cement stabilization. So it's basically cement treated base. This is cement treated sub base. Okay. Now if you see, there is another layer here. So why this another, like this additional layer has to be provided? Because this stiff materials will not be that much flexible in nature. Okay, because if the materials become stiffer, as you know, the beauty of flexible pavement is that it can flex, right? It can flex. I've also shown you earlier that it can flex like this, right? So whenever load comes, but if the materials become stiffer and stiffer, it loses its flexibility, and when it loses its flexibility, crack can happen. Crack can occur at the bottom of this, layers. So when cracks are like expected in these layers, then it will propagate easily to the upper layers. So we don't want the wearing course or binder course to be cracked, because once it cracks, water will come, and water will, like we know that aggregates are hydrophilic. That means they love water more than the bitumen. So bitumen is binding the aggregates. But when water comes, when there will be a crack, then water will penetrate, and when it comes in contact with water, the bitumen that is coating around the aggregates will simply strip off. Okay, that is called stripping. Stripping test you must have done in your transportation lab. So stripping of bitumen occurs. So bitumen will come out from the aggregates. So when there is no bitumen that is binding the aggregates, then the aggregates will be loose. So when traffic comes, those aggregates will come out. So ultimately, these cracks will lead to potholes. So that's why we need to ensure that these cracks don't get reflected on the top surface. Understood? So that's why this granular crack relief layer is introduced, so that if there is some crack in the cement treated layers, these cracks will not be reflected on the surface of the pavement. Okay, so this is granular crack relief layer where we use some aggregates. Okay, simple aggregates without any binding agent. Only aggregates are placed. 100 mm aggregate layer is placed. Okay, and if you want to use some like innovative materials like SEMI, which is stress absorbing membrane interface. So these are like rubber kind of materials, which is also used for the same purpose. That means if you have CTB or CTSB, cement treated materials, then in order to stop the propagation of this cracks to the upper layers, we can introduce this stress absorbing layer. It can be SAMI or it can be a granular crack relief layer, which is made of simple aggregates. And also, suppose as I said, there is like scarcity of materials, especially natural aggregates in today's world. So we need to find out alternative resources. So instead of using natural aggregates, what we can do, when especially when these pavements are recycled, that means the existing pavements are suppose distressed, then you must have seen that many times an equipment, a vehicle comes where it has an option of milling. That means it will mill the layer, mill the top layer of the pavement, and those aggregates will be like sometimes it is reused or sometimes it's thrown away. So instead of throwing those materials, you can again mix with your granular materials and you can use. This is called bitumen stabilized materials. Okay. Then instead of using both the layers, stabilizing both the layers with cement, you can stabilize only the base with cement, and this layer can be as it is GSB, or the other way around, CTSB, and this can be granular. So there can be different combinations that has been suggested in IRC. So if you look at IRC, you will see all these 6 different uh, design catalogs. And if you see here, some critical points are shown. So what are these critical points? So basically what happens, 2 things are to be noted. One is tensile strain, okay, at bottom of stiff layer, and second is vertical strain at top of subgrade. So this one leads to fatigue cracking and this one leads to rutting. So what is this fatigue cracking and rutting? So I'll simply come here. See, these cracks that you can see here, these cracks which are interconnected like this, these are called fatigue cracking. Sometimes they are also called crocodile cracking or alligator cracking. Because it looks like the skin of the crocodile or alligator. So why this happens, I already discussed, but still I will repeat once again. So whenever load comes on the top surface, and this layer, this bituminous layer, it has flexibility, so it will bend. Okay, it will bend like this. This is like this. When load comes, it will bend. Then when the vehicle moves away, it will again rebounds. Okay, it will bend, it will rebound, bend, rebound, like that. So when, because of this repeated bending, it will fatigue. The literal meaning of fatigue is, who will tell me what is the literal meaning of fatigue? What does fatigue means? Anyone? Fatigue means tired. So you are, so when you are tired, in France, tired is often called fatigue only. So like, so when this kind of phenomena happens repeatedly, so the pavement becomes tired and it fails in fatigue. So it's called fatigue cracking. What is rutting? So rutting, when suppose you have not compacted the layers, the bottom layers, especially the subgrade, the soil layer, well before putting the other layers, or maybe you have compacted but if you have not used good quality materials in this soil subgrade, then what may happen, when heavy vehicular loads such as trucks and all those vehicles they go, then this kind of depression may happen. So this depression generally starts at the subgrade level. Of course, there may be problem with the upper layers also. Okay, there may be some problem in the bituminous layer also. But in that case, suppose if these 2 layers are good. If this layer is good, this layer is good. Only problem in this layer. Then if a heavy vehicle load comes, then what will happen? It will be like this. But this material will not be depressed, right? So there will be, it will go up. It will form a cliff like this. So this material will be here. So if you see like distresses like this, where bituminous mix is shearing off, and it is forming some hips around its rough surface, then you can tell that the problem is only with the first layer. But if it if you see the depression is like this, that means this material is depressed at here, that means at the soil level. So then you can say that the problem is at the subgrade level. So simply, you know, so if you see this kind of situation, then what will do as an engineer? If you are asked for the solution, then what will do? Simply removing this layer and placing another layer, will it help? No, it will not help. It will again rot like this, because the problem is in the subgrade layer. But if you see the problem is like this, then simply remove the first layer and you can relay it. Okay, since now you understand what is fatigue and rutting, so let's go back and check here. So this fatigue, as you know, can happen only at the bottom of the stiffer layer. So in the first case, the stiff layer is the bituminous mixes. So wearing course and binder course together, we call this your like bituminous layers. Okay, layer 1. So at the bottom of the bituminous layer, there we need to check for fatigue, and when you need to check for rutting, that is vertical strain at the top of this subgrade. Okay, in this case, since this is a cement treated base, so you need to check the tensile strain here also, because this layer is also very stiff. You can check here as well, because this is cement treated surface, but cement treated base will be much stiffer compared to CTSP. So checking here is good enough. Okay, so here also you can see, like here under the bituminous layer, under the CTB and vertical strain above the subgrade. Okay, all right. So this is the most commonly used flexible pavement structure, at least in India. So where this layer is your wearing course, this layer is your binder course, this is your base, this is your subbase, and this is your subgrade. Okay, all right. So now, what is the design principle as per ISA 37/2018? So you are designing any road. Okay, you are designing any road. The design principle will be same. Not only road, or any kind of structure. So if you are designing a building, you must have been designing buildings, right semester guys, you must have been designing building for your 8th semester projects. So the design principle is always same. That means you need to ensure that the induced stress or induced strain, stress will be causing strain, so I am using only one term. So induced stress will be less than the strength of the material. So in this case, I am using strain, and I will be relating with the capacity or the allowable strain of the materials. That means I know what material I am using here in the subgrade, right? So with formula, I can find out what is the maximum capacity of this subgrade in terms of vertical strain. That means how much of vertical strain it can sustain without failing. Once we know its properties, that means what kind of soil you are using, what is the severe value of the soil that you are using, and all those things, if you know, then you can directly find out what is its capacity. Then you will have some vertical strain that is like, we can say it's the allowable. Okay, now some vehicles will come, vehicular load will come, and this vehicular load will exert some stress, and this, because of this stress, there will be some strain here. In the analysis of the pavement module, we learned like manual how to manually calculate, but of course here we will use software. But the philosophy is same. Because of this regular load, how much strain will be being generated. So this strain, suppose this is the allowable, and suppose because of this regular load, some strain is getting generated here, particle strain, that is your all expected. Okay, so this allowable should be always greater than the expected. Then only we can say that your pavement will sustain. Otherwise, the pavement will fail. Okay. Similarly, here also, then instead of epsilon v, we will call it epsilon t because it is tensile strain. Epsilon t. So here we will check, and in case of this vertical strain, that property was entirely dependent on the properties of the soil that you used underneath. And in case of tensile strain epsilon t, the in order to check what is the maximum tensile strain, that is entirely dependent upon the properties of the material that you have used here in the wearing course and binder course together. Okay, suppose, as I said, this epsilon v should be less than this, and again epsilon t, it should be again greater than expected. It should be, okay, I'm saying it should be. Then only you can say that the pavement is safe. Just like in your normal design of structures class, you will do like that, and you finally, if you find that it is safe, then you say the structure is safe. Suppose it is not safe. Okay, you have assumed some thickness, you have assumed some material properties, and suppose you have found out that it is not safe. That means the exerted or the expected strain is more than the allowable. Okay, then what will do? What will do? In case of building design, what do you do?
Sir, change the dimension.
Change the dimension. Very good. That is one option. Suppose this you are designing a. I'm just giving one example. You are designing one auditorium. Okay, on auditorium you are designing. So in between some pillars are there. Some pillars are there. Okay, so these columns will be taking the load, and you found out that because there is one more roof at the top, so where people will be sitting, so this dimension is not enough. Okay, so as you are saying, we will increase the dimension. So if you increase the dimension, the columns will be bigger and bigger, right? But you cannot afford to have big pillars inside an auditorium because it will obstruct the view of the audience, right? Then what will do?
Sir, increase the grade of concrete and steel, amount of steel.
Yes. So you will increase the material properties. You will use enhanced materials, right? So same case here also. Okay. So in that case, suppose this was an auditorium, and I said that you should not increase this and this. Now my question is to all of you that suppose there is no such kind of constraint that the dimension should be this much or it should be this much. You, as an engineer, you are free to decide anything. Okay. Then what you will do? Option one is increasing the dimension, and option 2 is increasing the strength of the material. That means you are using high quality materials. So which option you will go for? You can type your answers like in the chat box if you want. Option 1 or option 2. Option 2. Critical says option 2. Others? Tanmay, what do you think? You are also saying option 2. Others? All are saying option 2. Okay. But I am telling you, but in your design, what do you do? You have just written this design of structures, or now it's called structural design, right? Structural design subjects. So what do? You suppose it is not safe. You increase the dimension or you change the grade. What do you do? I think you go for option 1, right? Then why do you think it should be option 2? See, as an engineer, you simply like directly choose option 1 or option 2 just like that. Okay, you have to do cost analysis. Suppose you are using M40 grade concrete and the dimension of the column was this much, say 200 by 300. And if you use M50 grade concrete, the dimension of the column say 150 by 250. That means you have reduced the thickness. Okay. For M40 and in M50, what is the main difference? There will be more cement here, less water, right? So the cost of say one column you can figure out. Okay. If you are using M50 and if you are using M40, then how much? Because here the unit price will be less, but the dimension is more. But here, say per meter cube, I am saying, and here also per meter cube, so the unit price will be more, but the dimension is also less. So finally, if you see how many pillars are there, and you have to find out two figures, say rupees X and rupees Y. That means if you go for this option, this is rupees X, this is rupees Y, then you have to decide whichever is cost effective, you need to choose that. Okay, so here also you need to do like that, right? And here one more thing is there, that material requirements, because in case of one building it will be simply like say 4 or 5 pillars are there, so there is not much of, it doesn't make that much of difference. But here if you simply like reduce the thickness of one layer by say 10 mm, okay, 10 mm is 1 centimeter. If you reduce the thickness of this layer say by 1 centimeter, then imagine this layer will be like throughout the road. Say this road runs from Guwahati to Nagaon. So for that 140, it will be around 100 kilometers. Right? So for that 100 kilometer stretch, 100 kilometer into 1 centimeter, you will see how much volume of material can be saved. And bitumen is a costly material, so you can find out what is the percentage of bitumen used here. So like that you can see how much difference it will make. So it's not always about cost, sometimes it's also about the materials. That means in this case aggregate is not that costly, okay, compared to this first layer. The cost is less here, but if you increase the thickness, the requirement of aggregates will be more, and as we know there is scarcity of materials. So there are many factors, so you need to take into account of all the factors, because the company is paying you. Wherever you join, the company is paying you, so the more you save money for the company, the more the company will get benefited, and that will be reflected in your bonus, increments, all those things. So if like, so why they need experts. They consult experts, the companies, because they know that if the experts can suggest some little tweaks and twist, they can simply, even if they can simply like reduce the thickness by 1 centimeter, they will save in crores. Okay. So anyway, now as I said, one is permissible or allowable, and one is generated or expected. So this allowable should be always greater than the generated or expected value. So this epsilon t and epsilon v in both the cases. So here's the maximum horizontal tensile strain at the bottom of the bituminous layer. Okay. So this is calculated by the formula given in IRC and with the material properties that is known to you. And this generated has to be calculated either manually, if you have attended uh, this analysis classes, then you know how to do it manually, but that is limited to only, like there are some assumptions, like all in three layer theory we learned, but in there also the Poisson's ratio is assumed to be 0.5, but it may not be 0.5, it is generally 0.35. So if what if the Poisson's ratio changes, so for that we use software like CanPEF or IIT PEF. Okay, so there you need to simply put the value and directly epsilon t and epsilon v you will get. So simply you need to check. Okay, we will do one numerical there, you will understand. But before going into the numerical, you need to know many things. Although you are supposed to know all those things, but uh, I will be refreshing again these things so that you don't feel any discomfort while uh, going to the next section. So you know that the design traffic, okay, design traffic is calculated using this formula. So in this formula there are many parameters. If you see this R, N, A, D, F, okay. So what are these parameters? How these parameters are assumed or calculated, that we will learn in the next 15 or 20 minutes. Alright, so what is this actually design traffic? Design traffic basically means in 15 years or say 20 years, whatever is the design life of the road, the 15 years, that means you want to design the road for 15 years. That means you want to ensure that in 15 years of life the pavement doesn't fail, at least in rutting and fatigue. So if you want to do that, then what you have to do, you need to first find out how many repetitions of excels. That means this is, you already know what is excels, right? How many excels are there? So how many excels will be passing in 15 years? It may go like this, it may come like this. This same vehicle may go 100 times in a year on the same road. So that will be, all those things will be calculated, and finally we will find out how many excels will go through that road. And it is not only how many excels, it is how many standard excels. So what is standard excels? That means standard IRs, because all the excels will be carrying different loads. A XLY, a truck XL will be carrying more load than a bus XL because of the obvious difference in their load, right? So in truck also, if there can be an empty truck, there can be a truck carrying steel rods. So there will be difference in XLs. Okay, although if we simply count the XLs, but it will be like, we will be underestimating if we simply count the numbers and not take into account of the loads carrying by the excels, right? So we need to convert all those excels to standard ones. So standard ones we will see while designing this F, that is PDF, what is standard excels, how it is converted. So anyway, so this is A, initial traffic, D, lateral distribution factor. F, vehicle damage factor. And design period. R, annual cost rate. You already know those things, but still I will go through. So let's start with the first parameter, that is A. What is that? Is initial traffic. Okay, so initial traffic, the unit is commercial vehicles per day. That means here you are only concerned about the numbers of commercial vehicles per day. Okay, since you are multiplying by 365, that means you are converting to per year. So it has to be in per day, so you will be converting to per year. Then for 15 years using this you are predicting. But anyway, let's stick to this A, that is initial traffic. Now this initial traffic is a little bit confusing because on which day you need to consider the traffic, because traffic is always increasing. As you can see, there is a rate of growth, so traffic will be always increasing. So that means if you start constructing the road, okay, if you start constructing the road say in 2021 and the road gets finished in 2023, okay, and it is operational from 2023, but if you consider only the traffic that you counted on 2021 using traffic survey, then it is very very wrong, because in these 2 years also there will be some growth. So in order to take care of this growth, this formula is used. That means this A is basically P into 1 plus R to the power X. That is, X is the number of years between the last count. That means in 2021, when you counted for the last time before starting of the construction, and the year of completion of construction. That means in 2023. That means these 2 years needs to be considered, and then only you consider this A. Okay, so suppose here it was P, then on 2023 it will be P into 1 plus R to the power 2. Okay, so using A you need to, so this will be called your A. That means this A is the traffic in the year of completion of construction. Alright, you understood? Okay, now in this traffic also, like sometimes you have to consider the directional traffic and sometimes the both the traffics. So if it is a divided carriageway, that means like this, some vehicles is two-way, that means there is median in between, then only the directional traffic volume has to be considered as A. That means either this or this. Okay, if it is undivided, then the total traffic, this you have to add both, the total traffic will be your A. Okay, all right, any doubt in this A? No. Okay, now let's come to this D. What is this D? This D is lateral distribution factor. That means suppose in this my road I know that 100 vehicles, 100 CVPD, that means 100 commercial vehicles will be going per day, but all the 100 vehicles will not be channelized to only this particular lane. If it is there are more than 2 lanes, then some vehicles will go like this, some vehicles will go like this, some vehicles will go to the center, so it will be distributed. So laterally, that means laterally it will get distributed. So in that case you need not consider the entire 100 CVPD for design. You can reduce it. You can reduce it if the number of lanes are more than 1. That means for single lane roads, D will be 1 itself. That means 100%. All the 100% of the roads, 100% of the vehicles you need to consider. If it is intermediate lane, that means it is not double lane, but it is wider than your single lane roads, generally 5.5 meter. So in that case, you need to consider 75% only. That means D you need to put as 0.75. Similarly, if it is two lane, that means there are two lanes, one like this, one like this, then you need to consider only 50% because it will get equally divided. For four lane single carriageway, that means there is no median. Okay, only one line will be there. This yellow line you can see. So in that case, you need to consider D as 0.4. Okay, but if it is dual carriageway, that means there is a median. In that case, you know, your A will be no more the total traffic. A will be the directional traffic. That means on either in this direction or in this direction, whichever is higher. Okay, so only this direction. And if it is dual carriageway, that means if it is has one median here, and on each side if it has dual two lane, that means on each side it has two lanes like this case, then D will be 0.75. Okay, D will be 0.75. That means whatever the traffic you are considering here, okay, only in this, for that also you need to consider 0.75 or 75% only. You may ask why not 50%, because it will be divided here equally. But generally it is seen that in cars and all, the vehicles will be always trying to be on the inner lane. Okay, if there are two lanes, so you cannot directly say that it will be always following this lane. The high speed vehicles will be following the inner lane, low speed vehicles will be following the outer lane. So there are many factors. So but in case of if it is like two lane road both direction, then we can say that is only like in some exceptions of overtaking, generally doesn't go to that lane. So that's why it was 0.5 in case of two lane two way roads, but if in case of dual carriageway roads it will be 0.75. Similarly, if it is three lane, that means in both the sides if there are three lanes each, that is it's a 6 lane road, then it will be D will be 0.6. And if it is 4 lane, okay, double dual 4 lane, that means total 8 lane, then it will be D will be 0.45. So I hope you already knew these things and your memory cards are refreshed. Now coming to this F. This F is called vehicle damage factor, and in GATE you can expect to have at least one question on PDF. So pay attention. What is PDF? So as I said, the if I consider only the numbers of the axles, say two vehicles, one is truck, one is bus, both are single axle type, that means in rear it has single axles. But if I count them as one in each case, that will be not, that will be biased, because trucks will be generally carrying more loads. So we need to convert all those things to some standard value, right? If you remember in traffic engineering, you have learned one term called PCU, passenger car unit. That means we don't directly tell that this many vehicles are moving, because one vehicle can mean one truck, or one vehicle can mean one bike also, one cycle also even. So saying 1,000 vehicles are moving per hour, it's not a good idea. So we convert to PCU, that means passenger car unit. That means one passenger car, that means simple Maruti 800 or Alto, those cars will be considered as one. Their dimension will be considered as one. And in comparison to that, we convert. The truck will be having 4 or 5 PCU, a cycle will be 0.4, a bike will be 0.5, like that. if you remember all those things. So here also we need to convert. So while converting, how to convert, the IRC has suggested some standard loads. That means if it is single axle single wheels, that means like this, then the standard load is 65. This single axle dual wheels, like this, standard load is 80. This tandem axle dual wheel is 148. If it is tridem axle dual wheels, like this system, okay, then 224. So whatever the load it is carrying, you need to measure. See this, this is a axle pad. This is called axle pad. So you need to stop the vehicles. You need to ask them to like uh, come over and place the wheel over this axle pad, and you can measure its weight. Okay. Generally, if you measure only on this side, that means only on one side of the truck, on these two wheels, then the entire axle wheel will be simply doubled. That means here half of the wheel load has come, here the other half will come. So whatever the value you get here, you simply double it. All right. So in this kind of scenario, whatever, suppose you have got this is what dual wheel type. Think single axle dual wheel. This scenario, right? Two wheels are there. Suppose you got 160 kilonewton. It is carrying some uh, steel reverse reinforcement bars. So because of that, the weight is very huge, and the load is 160 kilonewton. Okay. Then do you think it is equivalent to two trucks carrying 80 kilonewton? If 160 kilonewton truck is there, then do you think it is equivalent to like two trucks carrying 80 kilonewton? Just answer that. Yes or no? You can type answer. Just type. Are you getting my question? It is carrying 160 kilonewton load. So can I assume that two standard trucks are going? That means two trucks carrying 80 kilonewton each. So can I do like that? Just yes or no, I'm asking. I'm not going to judge. I just want to know whether you know this thing or not. Okay, you want to point out. Okay, pointing out is good also, because many people will be simply logging in and not responding. Sujata, what do you think? It will be equal or? Okay. Bhargav? Bhargav does. Okay, I know you are there, but it will be equal or not. Shubhankar?
Sir, I guess it's equal to like two vehicles carrying 80 kilometer each.
Okay. It's like totally logical. It seems totally logical, right? That if two vehicles are there, 80 kilonewton, 80 kilonewton, then it should be equivalent to 160 kilonewton watt. But it's not. That's a tragedy. Okay. And the tragedy is such that it's not only like greater than the impact of two vehicles. That means it means that suppose this is my truck carrying 160 kilonewton. It passes over my road one time. Okay, one time. The damage it will cause to the pavement is say X. This damage can be in terms of anything, strain, stress. Generally, not in case of in terms of stress, strain. Okay, or the fatigue life that gets reduced. So the damage to the pavement, let's say it's X. Okay, then do you know how many? 160, right? So 80. Suppose I have reduced the weight by 50%. Now it is 80 kilometer. Okay. So I am saying that same damage, suppose the damage that is caused by these two vehicles will be say Y. Okay. And I am saying that X is not equal to Y. Now I am giving you one clue that the damage exerted or damage caused by this 160 kilonewton vehicle will be more, that means X will be greater than Y, then two vehicles with half of its loads. That means if it needs more vehicles to come, it needs more vehicles to go over the pavement. In order to make X equal to Y, more vehicles of 80 kilonewton needs to go. Okay, I am saying that 2 is not enough. Means 2 80 kilonewton truck is not enough to cause the same damage as a 160 kilonewton truck will cause. Now, can you tell how many trucks will be needed to cause the same damage of 80 kilonewton and it is 160 kilonewton? Shyamole, can you tell? Are you there?
Yes, sir.
Okay, any guess how many? It is not 2, so it will be 3, 4. How many will be needed? What do you think? The load is halved. That's where this PDF concept of PDF is coming. That means if you, the concept is like if you make the load 50% lighter, then you will need, that means you are reducing it by half. That means in that case you will need 2 to the power 4, 16 vehicles. 16 vehicles carrying 80 kilonewton will cause the same damage as a 160 kilonewton truck will cause. That's why this is called fourth power damage formula. Okay, fourth power damage formula vehicle. What else can you understand from this fourth power damage formula? That means if some vehicle is overloading, okay, that means you know that legal axle load is something, say 100 kilonewton for single axle truck. If some vehicle is overloading, that means it is taking say 200 kilonewton instead of 100. That means it's almost like 1600 kilonewton vehicles passing. So the severity of the vehicles on its pavement will be increased by like not 4 times, will be like how to say 4 গুণ হৈ যাব মানে. Okay, 2 to the power 4, sorry, 16 times হৈ যাব. আৰু যদি অকল 120 অকল 110 আনে, 110 আনিলেও will be 1.1 to the power 4, will be still 1.1 to calculate 1.1 to the power 4 কিমান হয়
So 1.46.
1.46 so you see অকল 10% increase করে it's like 1.5 times ডেমেজ বেছি ফৰ্ম হৈছে কিন্তু অকল 10%ত ডেমেজটো সিমান বেছি ৰিফ্লেক্ট নহয় যদি 2 times কৰি দিয়া it is 16 times যদি 4 times কৰি দিয়া it will be 4 to the power 4 16 into 16 256 times মানে এখন ভেহিকল যদি 4 times বেছি লোড আহে that means 256 খন ভেহিকল পাৰ হৈ যোৱাৰ নিচিনা ডেমেজ হয় that's why it's called 4th power damage load now as I said now we need to only since we are only considering the numbers of excels kiman msa how much msa will be there how much million standard excels will be there that's why million standard that standard term is there how much million standard excels will be there on its design life so we need to convert all the vehicles to standard excels that means if a vehicle is carrying 150 and it is tandem with dual wheels that means 150 by 148 to the power 4 whatever the value you get that will be our pdf like that now this kind of questions generally come in get suppose there are different bus and truck so single axle bus and tandem axle trucks so the front axle is this much rear axle is this much like that it's given all the loads are given how did you find out this load by doing this survey okay you have asked the truck to go over this weighing page all right so you have found out this now you need to find out whether here it looks like 1 2 3 4 5 6 7 8 9 10 11 12 here it looks like that only 12 axles are coming not 12 sorry this is front rear it will be double so it looks like 24 axles are there okay but it is not causing damage equivalent to 24 standard axles 24 standard axles so in order to find out how much this 24 axles is causing how much damage say it can be equivalent to 50 standard axles or whatever we'll find out now you need to find out the pdf so that pdf has to multiply it with this 24 and you will get how much damage it is causing equivalent to okay so we know for front axle the standard load is 65 because front axle will be always single axle single wheel right and for rear axle also it is single axle only so it will be again 65 axle but here it is truck okay truck and tandem axle that means sorry it's single axle it is dual wheel I think dual wheel and it is so there here it will be 65 standard load here it will be 80 here again it will be 65 for truck and this tandem axle for tandem axle dual wheel is 148 so here it will be 148 so we need to figure out how will you do let's see so this front axle is 22 so it will be you need to put 22.06 here divided by 64 to the power 4 that is called damaging effect so you will find if you do this you will find out 0.013 okay similarly for this see because this is dual wheel so you need to put 80 so 44.13 divided by 80 to the power 4 you will find out something like this okay so the damaging effect, you can simply add this plus this. That is for one bus. 1013 plus 1090, like that. Even if you don't do that, that is okay. But it is simply added 3.509. That means 3.509 times of these buses. Yate bus kekhon goise 1 2 3 4 5 6 buses. So 6 buses are causing 6 into 3.509, or say 3.5, almost 61, 21 numbers of buses গলে যিমান ডেমেজ হ'ব সিমান ডেমেজ কৰিব এই 6খন বাছে। তাৰ মিনিংটো এইটো, because the BDF is 3.509. Alright. Similarly, ট্ৰাকৰ ক্ষেত্ৰত চোৱা কিমান ডেমেজ পাইছা, 6খন আছে পাইছা 27.249. Why? Because এইকেইটাত তোমাৰ কিমান বেছি আছে দেখিছা, 245. This will be 245 divided by 148 all to the power 4. This much of damage. So that's why you should restrict overloading. তুমি যদি ৰাস্তা এটাত ভালে ৰাখিব খুজিছা, অকল এখন গাড়ী যদি তোমাৰ 10% overloading কৰি যায়, okay, যদি তোমাৰ 10% overloading কৰি তোমাৰ 10খন গাড়ীও যায়, আৰু যদি তোমাৰ 100% overloading কৰি মানে ডাবল লোড যদি কৰি তোমাৰ অকল এখন গাড়ীও আহে, তেতিয়া এই গাড়ীখনে বেছি ডেমেজ কৰিব এই 10খন গাড়ীয়ে যিমান ডেমেজ কৰিব তাতকে। কিন্তু ইণ্ডিয়াত কি হৈ আছে, অভাৰলোডিং কৰিলে সেম চালান কাটে। অ'কে, চ' গাড়ীবোৰে লাগিলে চালানৰ পইচাটো দি দিব, কিন্তু ষ্টিল 3খন গাড়ী বোলে গাড়ীত নাহে, কাৰণ সিহঁতে জানে যে লছটো সিহঁতৰে হ'ব যদি হেৰি কৰে, তাতকৈ চালানৰ পইচাটোৱে দি দিয়ে। কিন্তু কিমান লছ হৈ আছে, এইখন গাড়ীকো যদি এই 10% অভাৰলোডিং কৰিলেও যদি ইফ ইউ চাৰ্জ 1000 rupees, সিহঁতকো যদি চাৰ্জ 1000 rupees, that is not fair. So তোমালোক যদি ট্ৰান্সপৰ্টেশ্যন মিনিষ্টাৰ বনা কেতিয়াবা, then what you will suggest, এইটো তোমাৰ এই যেটো কি বুলি কয় চালানৰ এমাউণ্ট হয়, এইটো কেনেকৈ কেলকুলেট কৰিব ক'বা কোৱাচোন। How will you improvise this চালান fee? 10% আহিলে তুমি 1.1 times, এইটো আহিলে যদি just 2 times কৰি দিয়া, still it is not fair. তুমি 2 to the power 4 কৰিব লাগিব, তেতিয়াহে it will be fair. তেতিয়া সিহঁতৰ অভাৰলোডিং কৰাটো কমাব, এণ্ড তোমাৰ ৰাস্তাও বাচিব। অ'কে, চ' কেতিয়াবা কি হয়, ৱাইটেড এভাৰেজ PDF খোজে, মই PDFটো দি দিম বাৰু তোমালোকক, চ' ইউ কেন গ' থ্ৰু। চ' ৱাইটেড এভাৰেজ খুজিলে তোমাৰ বাছৰ কাৰণে ছাপ'জ এইখিনি উলিয়ালা, ট্ৰাকৰ কাৰণে উলিয়াইছে। জেনেৰেলি কি হয়, তোমাৰ ৰাস্তা এটাত ছাৰ্ভে কৰিলে চব টাইপৰ ভেহিকেল থাকিব, বাছ থাকিব, ট্ৰাক থাকিব, ট্ৰাইডেম ট্ৰাক থাকিব, LCV থাকিব, ত' চবৰ কাৰণে উলিয়াই। আৰু চবৰ কাৰণে যদি তোমাৰ কাউণ্ট বেলেগ বেলেগ হয়, 109 নাম্বাৰ্ছ অফ বাছেছ আছে, ট্ৰাক ইমান নাম্বাৰ্ছ আছে, LCV ইমান নাম্বাৰ্ছ আছে, দেন দ্য ৱেইটেড এভাৰেজ PDF is simply you need to do the take the weighted average, will be 2.61. নে তোমাৰ যিমানখন ভেহিকেলছ গৈছে, ছাপ'জ তোমাৰ 100 ভেহিকেলছ গৈছে, তাৰ লগত 2.61 মাল্টিপ্লাই কৰিব লাগিব। That means that 100 vehicles will be equivalent to 261 vehicles. Alright? Okay. But in some situations, you may not be able to weigh the trucks like this. Okay, survey is not possible. This is called Excel lot survey. This Excel lot survey is not possible. Say hilly road, or say it's a small scale work, so you don't want to engage any third party to do this kind of survey, because they will charge minimum 50,000 to 1 lakh rupees for conducting this kind of survey. So in that case, IRC has suggested that okay, if you don't want to do that kind of survey, then okay, you can assume. But while assuming also, you cannot simply assume random values. It says that you need to definitely do traffic survey. Traffic survey means you need to find out how many vehicles are moving. At least that you need to figure out. And when I say vehicles, I always mean commercial vehicles. And commercial vehicles mean what? We already discussed.
So greater than 3 ton.
Yes, when the load of the vehicles is more than 3 ton, then those vehicles are called commercial vehicles. Not those vehicles which has like yellow number plates. It has nothing to do with number plates. Commercial vehicles in pavement engineering means the vehicles that carries more than 3 tons. So those numbers of vehicles you need to at least count. But how will you know without measuring whether it is carrying more than 3 tons or not? You need to like use your experience. The truck will generally having always more than 3 tons. The bus will always be having LCVs also. So you can simply ignore the cars and bikes, and of course the cycles and all, and the rest you can count. So if the commercial vehicles per day is 0 to 150, then you can, for rolling or plain terrain, you can assume 1.7, for hilly terrains 0.6. If it is more than like this, so here two trends can be seen. Okay, so one is like when the commercial vehicle per day is increasing, its VDF is also increasing irrespective of the terrain type. Okay, second trend is compared to hilly terrains, the VDF of rolling or plain terrain is more irrespective of CVPD. So what do you think can be the reasons? Nowhere it's written. Even the reason I'm going to tell, it's only my assumption. So you guys are also welcome to give your assumption. So can you tell what can be the reasons? At least for the first trend, that means if the vehicles are more, that means the VDF will be more. These are completely two different sets, right? One is the number of vehicles, one is the vehicle load that is coming. So vehicle loads বাঢ়িলে মানে numbers বাঢ়িলে loads বাঢ়িব বুলি কি relation আছে? Generally, this kind of more CVPD you will see only on expressways or NH. So 0 to 150 তুমি ক'ত পাবা? খুব বেছিতে rural roadsত. So rural roadsত তোমাৰ ইমান heavy vehicle এনেও নাযায়. So that's why তোমাৰ the VDF is low. Okay, but if the CVPD is more, then there is a chance that it is either an NH or expressway. NH and expressway তোমাৰ বেলেগ বেলেগ টাইপৰ গাড়ী যাব, ৰাতি ৰাতি ট্ৰাক যায়, which are like transferring goods from one city to another city, like so it will increase. And what is the influence of terrain? So hilly terrainত কম কিয়, plain terrainত বেছি কিয়? Any guess? Shubhankar, any guess? মানে হিলি টেৰেইনত তোমাৰ ট্ৰাকৰ লোড কম তেনেকুৱা থাকে নেকি? Yes, of course we can tell, because it's hilly terrain. So those heavily loaded trucks you generally don't see climbing steep mountains. Okay, so that's why it will be always lesser than your plain or rolling terrains. Okay, so that is all about VDF. I hope you have understood. Next is design period. That means for how many years you are going to design the road. Because based on that only this figure will change significantly. So IRC has suggested that if we are designing a high density corridor, means uh, some expressways sort of roads, then minimum, minimum for 30 years you need to design. Alright. If it is national highway, then 20 years, state highway 20 years, urban roads 20 years, and all other categories 15 years. Okay. So national highway 20 years means develop national highway অসমত বনাই, they should not fail in 20 years. But আমাৰ 2 years so যায় জানো? নাযায়, no? What can be the reason? We'll see. So that is simply N. Now next thing is traffic growth rate, R. So R, how to calculate R? For that itself, one IRC code is there. Okay, IRC 108. So it's not a use code. 10-15 মান পেজ আছে নেকি, তাতে দিয়া আছে R কেনেকৈ calculate কৰিব লাগে. Okay, so when I was working in Lee Associates, there like I was given the task to calculate R. So for that I went to the statistical department in Khanapara. From there I collected the SDP or like SGDP, the state domestic gross product. So that means how much, at which rate it is increasing in the last 1 year. So from that there is some relations and you can find out this R percentage. But generally the GDP growth is like in India now, it's GDP is increasing in a very good rate, right? So minimum 5% you need to consider. It's not directly related to GDP. মানে GDP তোমাৰ নেগেটিভ কৈছে মানে কি তুমি নেগেটিভত কৰিব জানো, 20 বছৰ পিছত বোলে তোমাৰ গাড়ী এখন নে দুখনে ওলাইছে এমএসএ. It's not like that. It depends on many other factors as well. Past trends বা কিমান গৈছে আৰু কিহৰ ওপৰত ডিপেণ্ড কৰিব পাৰে কোৱাচোন, কিহৰ ওপৰত R ডিপেণ্ড কৰিব পাৰে? And it's just philosophical answer, but yeah. R মানে বুজিছা ন, what is R? R is the rate of growth of traffic. মানে তোমাৰ আজি যদি তুমি গৈ বাহিৰত চোৱা, তুমি যদি 1 ঘণ্টা থিয় হৈ তুমি গাড়ী কাউণ্ট কৰা, তুমি যদি 100খন গাড়ী দেখা, তুমি 5 বছৰ পিছত তুমি 100খন নেদেখা, তুমি 200খন দেখিবা. What can be the reasons why it is increasing? So কিমান ৰেটত ইনক্ৰিজ হৈছে সেইটো of course GDP ওপৰত ডিপেণ্ড কৰিব, কাৰণ GDP বেছি হোৱা মানে তোমাৰ সেলস বাঢ়িছে, অমুক বাঢ়িছে, সব মানে তোমাৰ ৰিলেটেড গুডছ ইম্পৰ্ট এক্সপৰ্ট বেছিকৈ হ'ব, মানুহৰ ইনকাম বাঢ়িব. চ' GDPৰ লগত এটা ডাইৰেক্ট ৰিলেশ্যন ইজ দেয়াৰ. বাট আদাৰ থিংছ আৰু কেনেকৈ উলিয়াব পাৰিম, কিমান গাড়ী বাঢ়িছে সেইটো যদি তোমাক উলিয়াব পাৰোঁ, আৰু কি উপায়েৰে উলিয়াবা কোৱাচোন? When I took the same class and asked the same question to the JIST students, they could answer. So at least তোমালোকে ক'ব পাৰিব লাগিছিল শ্যামলি, আৰু কি উপায় থাকিব পাৰে কোৱাচোন? Simple উপায়. You can simply go to the dealers who are selling trucks. Okay, then সিহঁতক সোধা অটোমোবাইল ইণ্ডাষ্ট্ৰি কিমান ৰেটত গ্ৰ'থ কৰি আছে. So that can be directly related to that also. So generally you can take 5%, whatever the value you assume, more than 5%, it's okay. 5 কিছুমানে 6 ধৰে, 6.5, 7.5, up to 7.5, everything is okay. More than 7.5, you need to give justification. Why? Okay. Now, as I said, this epsilon T and epsilon V, two types are there. One is allowable, one is expected. That means one is related to the material properties, one is related to the load that is being applied on the pavement. So sorry, epsilon v, here also epsilon t, epsilon v. Now you need to know that uh, epsilon v is related to the epsilon v. Where did you consider? Is the vertical strain, and we considered on the subgrade, right? And it was related to rutting. So how much epsilon v is allowed? Okay, how much epsilon v is allowed from for that total traffic? Okay, nr and n design is same. That means whatever the formula you have. Uh, so first step is to figure out all these parameters: a from traffic survey, d from the geometry, like how many lanes are there. From that you can know d, f from axial load survey. You need to calculate VDF, and if it is this axial load survey is not possible, you can simply take the values as suggested in IRC. Then R, what is the rate of growth? N, depending upon the class of the road. Then if you know all those things, you can find out N design. Okay, N design will be something like 80 to 100 into 10 to the power 6. So we call it, it is 90, then 90 MSA, million standard excels. So once you know this, you can back calculate and find out what is the limiting value or what is the allowable value of epsilon v and epsilon t. This epsilon v is for rutting criteria and epsilon t is for fatigue criteria. This nf and design both are same. Okay, it's written nf. Okay, so these are the two formulas. Generally we use the 90% reliability, because for expressways and national highways we use this 90% reliable. That means this formula will give you some results that is 90% reliable. So this one is used. We don't use this one. Okay. Similarly here also we use this one. So that means if we calculate this, we can find out what is epsilon v directly. Here also if you find out nf, which is basically n design, we can find out epsilon t. There are some other terms as c, m, r, m. We will discuss what are these things. But that is found out like this. That means the first step is to calculate the total design traffic, and then you can find out this allowable strains. So now this c here, okay, this c here is 10 to the power m. And what is m? M is this. Like so basically this VB, VA, all those things are, VA is percent of air voids in the mix. So if we place the bituminous mix and compact it using rollers, there will be still some voids inside. So this is percent of air voids. PV is percentage of effective bitumen. So how much bitumen is effective? Effective means excluding the percentage of bitumen that is absorbed on the aggregate pores. So what is the effective bitumen? So if you know these things, you can find out M. Okay, and for different mixes, generally this PA, PB all are given. So basically C is given in all the cases. So in our case, that is the pavement design catalog A, where 2 layers of bituminous layers, 2 layers of granular layers, and then subgrade, that is was A, if you remember. So for that, based on the traffic, these things are already given. So generally it's 2.35, because traffic will be always higher than 50 MSA. Okay, so you'll be able to find out. So once you are able to find out what is C, then you can use it here and find out what is NF. But if you see, there is one more term, MRM. What is this? That is nothing but elastic modulus that we used in our analysis class. Elastic modulus of the layer. This is basically resilient modulus, not elastic modulus. Both are different, but in analysis we can consider both as same, even in design. Okay, so that is your MRM. So if you know what kind of material, what kind of what grade of bitumen you are using, you can find out MRM. I will show you in the later slides. Similarly, if it is a cement treated base or cement treated sub base, for those layers also, because if you remember, if it is a CTB, then here also some tensile strain was generated, because as I said, it was a stiff layer. This was your bituminous layer. Here also tensile strain will be generated. Here also tensile strain will be generated. So in that case, how to find out the tensile strain in case of the cement treated base or cement treated sub base? So for that, you still same n, whatever you find out using the formula 365 into that, then you need to use this formula. So where RF is the reliability factor, if it is expressway and national highway, you need to use 1. For all other cases, you need to use RF equal to 2. Then N, standard axle reputations that it can sustain, that is basically N design, whatever you calculated earlier. Okay, then E is the elastic modulus of the CTB layer. Then epsilon T you can find out using this equation. Alright. Now, now the thing is how to calculate the properties, the elastic modulus. No? Elastic modulus. In analysis class, it was already given in the question. That elastic modulus of the first layer is this much of megapascal, second layer is this much of megapascal. Okay. Same elastic modulus or modulus of resilience, both are same. I will be using both the two terms invariably, so don't get confused. Okay, so this E and MR, how you can calculate. So we will see for all the layers how to calculate this elastic modulus. So for finding the elastic modulus of the bottommost layer, that is subgrade is the bottommost layer, right, which is made up of soil alone. So for that, the correct method is to perform triaxial test, because triaxial test, the king of all the tests in soil mechanics. So it gives you the idea of many things. So from that cyclic triaxial test or repeated triaxial test, you can find out modulus of resilience. But not all the institutes or not all the departments will be having this triaxial test setup. So in that case, how to find out the elastic modulus or modulus of resilience? So we do severe test. Okay, you take some sample and you do severe test. So severe, as we know, California bearing ratio. So it says it gives the strength of the soil relative to the aggregates that is found in California. Okay, because those people thought that material or aggregates that is available in California that was having the highest strength. So severe value is calculated based on that. Okay, let me ask you one question. Can severe value be more than 100%? This material can be anything. Can it be more than 100%? Okay. Are you there?
Yes, sir.
Okay. So can it be more than 100%? What do you think? So Vishal says yes, it can be more than 100%. Or no? Okay.
Sir, yes.
Yes. Others? Kritika. Can severe be more than 100%? Sujata says IG মানে বুঝে না ফেলো in some cases but not common. Okay. Yes, Sujata. So What are those cases when severe value can be more than 100%? See, that's the problem with you guys. তোমালোকে চব পঢ়িছা, চব জানাও, কিন্তু মানে ক্ৰিটিকেলি নাভাবা বস্তুবিলাক। চিভিয়াৰ টেষ্ট কি হয়? মই মাত্ৰ ক'লোঁ চিভিয়াৰ টেষ্টত তোমাৰ এগ্ৰিগেট লয় বা চইল লয়, য'ত তোমাৰ দেন লোড এপ্লাই কৰে। লোড এপ্লাই কৰি কি হয় 2.5 mm পেনিট্ৰেশ্যন কৰিবৰ কাৰণে কিমান লোড দিব লাগিছে, জেনেৰেলি কিমান 1370 kg লাগে, 5 mm কাৰণে 2055 kg লাগে, ৰাইট? চ' এতিয়া ষ্টেণ্ডাৰ্ড এগ্ৰিগেটছ মানে কেলিফৰ্ণিয়াত যিটো এগ্ৰিগেটছ পাইছিলে তাতে কিমান লোড লাগিছিলে 2.5 mm, কাৰণ তাতে কৈছে যে এইকেইটা বহুত ভাল কোৱালিটিৰ এগ্ৰিগেট। ত' তাতে তোমাৰ 2.5 mm পেনিট্ৰেট কৰিবৰ কাৰণে যদি ইমান ভাল কোৱালিটিৰ আছিলে তাতে মেবি তোমাৰ 13,700 kg লোড দিব লগা হৈছিলে 2.5 mm পেনিট্ৰেট কৰিবৰ কাৰণে। অ'কে, ইয়াতে চৰি কি কৈ আছোঁ মই, তাতে লাগিছিলে তোমাৰ 1370 kg ষ্টেণ্ডাৰ্ডত। এতিয়া তোমাৰ ইন ইয়ৰ কেছ চাপ'জ তোমাৰ 137 kg লাগিছে, অ'কে, অলৰাইট। চ' ইন ডেট কেছ তোমাৰ চিভিয়াৰ ভেলু কিমান হ'ব? 1370 by 137 by 1370, that means 10%. But is it true that কেলিফৰ্ণিয়াত যিটো এগ্ৰিগেট পায় সেইটোৱে তোমাৰ একদম চবতকৈ ষ্ট্ৰংগেষ্ট এগ্ৰিগেট? ইট মে নট বি। ক'ৰবাত তোমাৰ আফ্ৰিকাৰ ক'ৰবাত জংঘলত তুমি যদি এগ্ৰিগেট পোৱা which is even stronger than those California aggregates, that means তাতে তোমাৰ 1370তকৈ বেছি লোড ছাষ্টেইন কৰিছে 2.5 mm পেনিট্ৰেশ্যনত, যে মে বি তোমাৰ ডাবল 2740। ইন ডেট কেছ তোমাৰ চিভিয়াৰ ভেলু 200% আহিব। It's not like that. It's not like that. It will be always be less than 100%. But we are considering aggregates and soil. Itu tomar aggregates koisile, aggregates particles will be more stronger. Soilot koile ekane bahut kome ahe hoday. Kintu still, if you intend to use, soil in subgrade, should not be more than some percentage. Visit pavement পঢ়াইছিলো। Anybody remembers কিমান হ'ব লাগে মিনিমাম চিভিয়াৰ পাৰ্চেণ্টেজ তোমাৰ পেভমেণ্ট এপ্লিকেশ্যনৰ কাৰণে? 8%। 8%তকৈ তলত হ'লে ইট শুড নট ইউজ। বাট ছেডলি অসমত যিমান চইল আছে চবৰে তোমাৰ চিভিয়াৰ ভেলু লেছ দেন 8%, আৰু সেইবোৰে ইউজ কৰা হয়। সেইবোৰ ইউজ কৰে, সেইকাৰণে ৰাস্তাৰ এই অৱস্থা। One of the reasons মই কোৱা নাই যে because of that. Anyway, so the thing is we need elastic modulus or modulus of subgrade reaction, because you know that in order to find out the like allowable to ওলাব গম পালাই NF উলিয়াই কেনে তুমি এইকেইটা ফৰ্মুলা ইউজ কৰিলে তুমি allowable কেইটা পালা, ৰাইট? এইটো কৰিলে তুমি ফেটিগৰ কাৰণে allowable পালা, এইটো কৰিলে তুমি ৰাটিঙৰ কাৰণে allowable পালা। That means epsilon V and epsilon 2 allowable you got, but you need to find out what is the permissible, sorry, that is not allowable, that is expected, but you need to find out what is allowable because of the material like iman allow koribo pare. All right, so for that we need to find out these strains using the software or the analytical techniques that we learned in our second module. Jones table আৰু কিবা কিবি চাৰ্ট কৰিছিলা ন, চাৰ্টবিলাক ইউজ কৰি তাতে কি লাগে মেইনলি দুটা বস্তুৱে লাগে, ইলাষ্টিক মডুলাছ এণ্ড পয়জনছ ৰেচিঅ' এণ্ড অফক'ৰ্ছ দ্য থিকনেছটো আমি এজিউম কৰি ল'ম ফাৰ্ষ্ট, বাট টু থিংছ আৰ ৰিকুৱাৰ্ড, ইলাষ্টিক মডুলাছ এণ্ড পয়জনছ ৰেচিঅ'। চ' what do you need to know? Elastic modulus. But আমি ইলাষ্টিক মডুলাছৰ কাৰণে ট্ৰাইএক্সিয়েল টেষ্ট কৰিব নোৱাৰোঁ, চ' আমি কি কৰিম? চিভিয়াৰ টেষ্ট কৰিম। কৰিম চইলৰ চিভিয়াৰ টেষ্ট কৰি কেনে ছাপ'জ এটা ভেলু পালা তুমি 8% পালা, 9% পালা, 4% পালা, কিবা এটা পালা, দেন দিছ ফৰ্মুলা ইজ ইউজ। ইফ দ্য চিভিয়াৰ ভেলু ইজ লেছ দেন 5%, দেন modulus of subgrade reaction is directly 10 times of CVR. মানে 4 যদি পাৰ্চেণ্টেজ হয়, that means it is 40 megapascal. Okay, it is in megapascal. That means 40 megapascal liquid bubble. If it is less than 5%, then the relation is complicated. 17.6 into CBR to the power 0.64. So এটা তুমি যদি 8% আহে 8 বহাই দিলে হ'ল ওকে কিবা এটা পাবা আৰু অলৰাইট আৰু Poisson's ratio which is the another parameter that is required for pavement design that is mu is generally 0.35 okay generally for all the layers it will be 0.35 except for cement treated base and cement treated sub base that means bituminous layer to 0.35 granular layers to 0.35 and subgrade to 0.35 Poisson's ratio okay now you know this is your bituminous layer two layers are there anyway these two layers are granular layers and this was your subgrade anyway infinite okay so yate tumi subgrade or CBR uliala and yate akol tumar elastic modulus to lage right E and mu of all the layers E and mu so Poisson's ratio mu 0.35 follow E uliala already using CBR now for the above layers mu keta jana above layers of tumar ki lage E lage right E1 and E2 all right so E1 and E2 let's see how to calculate E2 so in order to calculate E2 we use this formula that is basically your E2 that means here if you look at the formula this is AMR support that means this is your E3 basically a subgrade means support so this is MR support auxiliary modulus of the supporting layer in this case what is the supporting layer subgrade so a G uliala MRS emoto uliasila no this will be your this MR support okay and you need to know H is the thickness of the granular layer so H is the thickness of the granular layer so in mm suppose tomar 100 mm ase then you calculate E2 based on that okay but yate eta tomar problem ase ki problem ase concept eta problem ase tumi ei layer tor elastic modulus or modulus of resilience kiman hoy uliasa based on what তুমি ইয়াতে কি মেটেৰিয়েল ইউজ কৰিছা সেইটো চোৱাই নাই দেখোন ইয়াতে তুমি চাইছা যে ইয়াৰ থিকনেছ কিমান হয় তলত কি লেয়াৰ ইউজ কৰিছা তো ইয়াতে কি মেটেৰিয়েল ইউজ কৰিছা সেইটো চোৱাই নাই সেইটোৱে তোমাৰ ফ্ল হয় আইএসিত ওকে কিন্তু আইএসিত কোৱা নাই যে তুমি এইটোৱে ল'ব লাগিব এইটো তেতিয়াহে ইউজ কৰিবা যেতিয়া তোমাৰ ট্ৰাইএক্সিয়েল টেষ্ট সেটআপ নাথাকে ওকে in that case you can use this formula then cement treated base or cement treated subbase or surface tate tumar jeto elastic modulus ECTSB you can calculate 1000 into UCS is unconfined compressive strength 28 days okay to jana no UCS test korisa already so this is calculated like that this is practical this is logical also karan yate tomar at least material to test kori kane uliasa okay yate but as I said Poisson's ratio this is cement thakar loge tomar the material becomes stiff so it will be 0.25 concrete or Poisson's ratio kiman hoy konoba kobo pariba see granular layer already rekhilai soil or 0.35 by aggregate bituminous mix ebilakor 0.35 dekhila cement add kori dia loge dekhila je soil layer or tomar komi goise 0.25 so concrete or kiman hoy use korisa jane concrete or Poisson's ratio use kora nai radius of relative stiffness uliata to use kora nai pH cube by 12K 1 minus use kora no concrete slab hoy na concrete or 0.15 no the stiffer the material is Poisson's ratio will be lesser and the elastic modulus will be higher and higher all right Okay. So next তুমি granular base layer. So granular base layer to তোমাৰ দুটা কেছ হ'ব পাৰে। গ্ৰেনুলাৰ বেছ লেয়াৰটো যদি তোমাৰ ডিৰেক্টলি গ্ৰেনুলাৰ সাব বেছ লেয়াৰৰ ওপৰত থাকে দেন তুমি দুটা সেম কম্বাইন কৰি কেনে ডিৰেক্টলি তুমি এমআৰ সাপোৰ্টৰ পৰা উলিয়াই দিয়া। ওকে, এইচ2 তেতিয়া কম্বাইন হ'ব। কিন্তু যদি তোমাৰ তলত চিটিএছবি থাকে দেন ইউ নিড টু টেক 300 or 350 এম্পা। ওকে, and poison ratio will be 0.35 anyway. So আমি numerical কৰিলে you will get clear. Cementitious বেছত তোমাৰ same 1000 into UCS. So UCS তোমাৰ unconfined compressive strength at 28 days, so 4.5 to 7 ampere ভিতৰত থাকে। So তুমি তেনেকৈ উলিয়াই 4500 পৰা 7000 megapascal হ'ব। Alright, so তুমি 5000 ampere generally লয়। Okay, now if you use cement treated base, then you know that in order to avoid propagation of this crack to the upper layers, we use some crack relieving layers. That crack relieving layers can be aggregate interlayer, that means তুমি aggregate ইয়াতে দি দিব পাৰা এনেকৈ ডাঙৰ ডাঙৰকৈ, or তুমি stress absorb membrane interlayer, stress absorbing membrane interlayer এইটো দিব পাৰা। Okay, so in that case যদি তুমি সামি ইউজ কৰা দেন সেইটো তোমাৰ বেলেগ লেয়াৰ হিচাপে কনচিডাৰ কৰিব নালাগে। Okay, but if you use aggregate interlayer then it will be it has to be considered as a separate layer যাৰ তোমাৰ elastic modulus 450 megapascal and mu 0.35 হ'ব। That means তুমি যদি ইয়াতে এনেকৈ এনেকৈ ৰাখিছা তোমাৰ যদিও তোমাৰ তিনিটা মেইন লেয়াৰ্স আছে মাজৰ যিটো crack relieving layer আছে সেইটো এটা লেয়াৰ কৰিব লাগিব, মানে তোমাৰ 4 লেয়াৰ হৈ যাব, U1 E2 E3 then E4। ওকে, 4টা লেয়াৰ আহি যাব। আৰু যদি চিটিএছবিও বেলেগকৈ দিয়া দেন তোমাৰ 5টা লেয়াৰ হ'ব। অলৰাইট, চ' এইটো হ'ল তোমাৰ বেছিক কনচেপ্ট। এতিয়া তুমি অলৰেডি গম পালা এইকেইটা E3 μ3 দুটা উলিয়ালা, E2 μ2 উলিয়ালা, μ1টো অলৰেডি জানাই 0.35 চেম বুলিয়ে কৈছিলোঁ গোটেইকেইটা লেয়াৰৰ, if it is unless and until it is cement treated it will be 0.35. So the only thing is E1 is যিটো তোমাৰ টপ ভিটামিনাছ লেয়াৰ্ছ আছে তাৰ তোমাৰ মডুলাছ অফ ৰিলিজেন্স অৰ ইলাষ্টিক মডুলাছ কিমান হয়। তো তাৰ কাৰণে তোমাৰ জেনেৰেলি দিয়া আছে বেলেগ বেলেগ মেটেৰিয়েলছৰ কাৰণে। তো তুমি যদি VG10 viscosity gap 10 ভিটামিন ইউজ কৰা আৰু তোমাৰ এভাৰেজ এনুৱেল টেম্পাৰেচাৰ ইন দ্যাট লোকেশ্যন ইজ গিভেন ইন লাইক ডিফাৰেণ্ট। চ' গুৱাহাটীত হ'লে কিমান হ'ব, এৰাউণ্ড চাই ল'বা কিমান হয়, 30 মান আহিব নেকি, 30 যদি আহে দেন তুমি কি ভিটামিন ইউজ কৰিছা VG40 সাপোজ দেন তুমি 4000 megapascal ল'ব লাগিব। ইফ ইউ আৰ ইউজিং মডিফাইড ভিটামিন দেন 2400। অ'কে, ইফ ইউ আৰ ইউজিং VG30 ইমান, চ' এনেকৈ ল'ব লাগিব। অ'কে, আৰু এতিয়া কোনটো ভিটামিন ইউজ কৰিব লাগে সেইটো কেনেকৈ গম পাবা, সেইটো তোমাৰ ইয়াতে ট্ৰেফিকৰ ক্ষেত্ৰত দিয়া আছে, ইমান হ'লে ইমান ল'ব লাগিব, ইমান হ'লে ইমান ল'ব। মই যেতিয়া ভিটামিনাছ মিক্সৰ ক্লাছ বা পেভমেণ্ট কনষ্ট্ৰাকশ্যনৰ ক্লাছ ল'ম তেতিয়া মই ভালকৈ দেখাম কোনটো ভিটামিন কেতিয়া ল'ব লাগিব। বাট ইন দিছ কেছ ইউ অলৰেডি ন' what vitamin grade has to be used. Okay, now to summarize all the things, আমি বেলেগ বেলেগ লেয়াৰ পালোঁ। তো ভিটামিনাছ লেয়াৰ্ছ উইথ VG40 or modified vitamin হ'লে তুমি ইলাষ্টিক মডুলাছ ই কিমান ল'বা 3000 এম্পা, অৰ টেষ্টেড তুমি যদি টেষ্ট কৰিব পাৰা গুড, টেষ্ট কৰা, টেষ্ট কৰি যিমান আহে একজেক্ট সেইটো লোৱা, অৰ 3000 এম্পা হুইচ এভাৰ ইজ লেছ। পয়জন ৰেচিঅ' 0.35। যদি VG30 থাকে, VG30 মিনছ ভিস্কচিটি ইজ লেছ, ৰাইট। VG30ৰ ভিস্কচিটি কিমান হয়, এইটো জানা ন? অ'কে, VG মানে what is VG? Just type in so that I get whether This term is new or you already know what is VG? VG is viscosity grade. Viscosity grade, bituminor belek grade থাকে না? VG10, VG20, VG30, VG40. So this is VG30. That means its viscosity will be 30 into 100 plus minus 20 poise. মানে তোমার 2400 পৰা 360 100 পয়জলৈকে থাকিব। যদি ভিজিট 10 হয় that means তোমাৰ 800 to 1200 100 plus minus 20 ৰে মাল্টিপ্লাই কৰিব লাগিব। 800 to 1200 পয়জৰ ভিতৰত তোমাৰ ভিস্কোসিটি থাকিব। Okay, dynamic viscosity. Anyway, so if you know which bitumen grade is to be used, then you can do like that. Cement treated base হলে ইমান হ'ব, recycle base আৰু বহুত কিবা কিবি আছে এনেকৈ ল'ব পাৰে। ইমিনাইট্ৰেল হ'লে ইমান, ইমিনাইট্ৰেল সাবফেজ হ'লে ইমান, আনবাউণ্ড বডিলাৰ হ'লে এনেকৈ উলিয়াবা। All those things are given. That is a summary table. Now তুমিতো এটা ট্ৰায়েল ল'ব লাগিব, এজিউম কৰিব লাগিব। First you need to assume some values to start with. যেনেকৈ তোমালোকে বিম এটা ডিজাইন কৰিলে ফাৰ্ষ্ট ইউ এজিউম ডেট 250 mm উইথ হয়, 300 mm ডেপ্থ হয়। এটাতো কিবা এটাতো এজিউম কৰা ন? কেনেকৈ এজিউম কৰা? হাউ ডু ইউ এজিউম? উইল টেল। 250 কিয় লোৱা? 300 by 300 কিয় নোলোৱা? তোমালোকে কিয় এনচাৰ নিদিয়া মই নাজানো দে। Okay, leave it. In case of pavement, this first assumption, it is given in IRC in as different, like catalogs, or it's called plate. So IRC খন যদি IRC 37 যদি খুলি চোৱা তেতিয়া দেখিবা যে বহুত প্লেটস দিয়া আছে। প্ৰত্যেকখন প্লেটছতে তোমাৰ দেখিবা যে CBR ভ্যালু ডিফাৰেণ্ট 8%। ইয়াতে তোমাৰ ট্ৰেফিক দিয়া থাকিব বেলেগ বেলেগ, তাতে তোমাৰ পেভমেণ্ট থিকনেছটো এজিউম কৰিব পাৰা। সাপোজ তোমাৰ ট্ৰেফিক ক্যালকুলেট কৰিছা, তোমাৰ 80 MSA আহিছে, 80 MSA আহিছে, বা সে 40 MSA আহিছে, 40 MSA আহিছে। 40 MSA আহোঁতে তুমি কি কৰিবা? ইয়াতে চাবা 40 MSA কাৰণে কিমান হয়। তাতে তুমি CBR বেলেগ বেলেগ আছে। সাপোজ CBR তোমাৰ 8% আছিলে, সো এইখন প্লেট নম্বৰ 4 ইউজ হৈছে। ওকে, প্লেট নম্বৰ 4 ইজ ফৰ ইফেক্টিভ CBR 8%। ওকে, সো তাতে তুমি 8%ত গলা, 40 MSA পালা, তুমি দেখিলা যে ওকে এইকেইটা থিকনেছ দিয়া আছে। ওকে, বাট IRC 37 says that if the traffic is more than 2 MSA, that means যদি rural roads নহয়, okay, in that case তুমি এনেকৈ ডাইৰেক্ট উলিয়াব নোৱাৰা। This is wrong. In IRC 2001 version তাতে তোমাৰ ডাইৰেক্ট উলিয়াইছিলে, but now it's not like that. ইয়াতে তুমি এটা জাষ্ট প্ৰিলিমিনাৰী আইডিয়া পাবা কিমান হ'ব লাগে। ওকে, 50ৰ ওপৰত দিয়া নাই, সো 50ত যিমান আহে, সাপোজ তোমাৰ যদি 80 MSA আহিছে, দেন তুমি 50ৰ কাৰণে যিমান দিছে সিমান ধৰি কেনে এইটো তোমাৰ ফাৰ্ষ্ট ট্ৰায়েল ধৰিব পাৰা। আৰু ফাৰ্ষ্ট ট্ৰায়েল কেন বি সাৰফেস কোৰ্স, দ্যাট মিন্স তোমাৰ এণ্ড বেস এণ্ড বাইণ্ডাৰ কোৰ্স WMM GSP। সাৰফেস এণ্ড এইটো বেসটো কনসিডাৰ নকৰিবা, বাইণ্ডাৰ কোৰ্স। সো সাৰফেস প্লাস বাইণ্ডাৰ মিলি তোমাৰ বিটুমিনাছ কোৰ্স হয়। তো তোমাৰ এই দুটা মিলি তোমাৰ ফাৰ্ষ্ট লেয়াৰ 1 বিটুমিনাছ কোৰ্স। দেন তোমাৰ WMM এণ্ড GSP, এই দুটা লেয়াৰ মিলি তোমাৰ দিস ইজ বেস, দিস ইজ সাব বেস, এই দুটা লেয়াৰ মিলি তোমাৰ লেয়াৰ 2 আমাৰ তিনিটা লেয়াৰ ধৰা যায় ন। থাৰ্ডটো তোমাৰ সাব গ্ৰেডটো তোমাৰ থিকনেছৰ কোনো কথা নাই। ওকে, সো তুমি লেয়াৰ 1ৰ থিকনেছ 155, লেয়াৰ 2ৰ থিকনেছ 450, এইটো তোমাৰ ফাৰ্ষ্ট এজাম্পশন লৈ ইউ নিড টু start designing. Okay, so now this is a challenge where we need to construct a new road, greenfield project, That means brownfield project মানে তোমাৰ already existing workshop তুমি যদি আকৌ নতুন কৰা এইটো greenfield project means নতুন একদম so already এইটো ৰাস্তা exist কৰে আমি এটা নতুন ৰাস্তা বনাম এনেকে তেলেংগানা হয় আমাৰ চেন্নাই to মুম্বাই কানেক্ট কৰিব okay so in that case তুমি how will you start designing okay or you start so design the road flexible pavement finding out different thickness of or that means the find out the thickness of different layers so we will do that let's do so the first step is what to find out this the design traffic you should know for how much traffic you are going to design all right so uh, how it's calculated we learned all the parameters one by one so let's see ইয়াতে তোমাৰ কি কি দিয়া আছে কি কি এজিউম কৰিব পাৰা so first কি লব তোমাৰ a টোৰ কাৰণে তোমাৰ p লাগে 1 plus r to the power x right ইয়াতে তোমাৰ p আৰু x টো তুমি এজিউম কৰিব পাৰা 2 years to এজিউম কৰিছো okay then p টো তোমাৰ দিয়া নাই but generally it needs to be collected from traffic survey or origin destination survey যদি ৰাস্তাটো নাইয়ে তোমাৰ ইয়াতে ৰাস্তা এক্সিষ্ট নকৰে তুমি ইয়াতে গৈ ক'ত সাৰ্ভে কৰিবা in that case তুমি কি কৰিবা ইয়াৰে মানুহক সুধিবা চেন্নাইৰ মানুহক যে do you like to যদি এটা ৰাস্তা হয় এনেকুৱা ফেলৰলৈকে নতুন ৰাস্তা will you prefer that road or you will use the existing road ফেলৰলৈকে যোৱা নাই মই নতুন ৰাস্তা ল'ম okay shortcut হ'ব then তুমি ইয়াৰ পৰা কাৰণ চেন্নাইৰ পৰা মুম্বাইলৈ থৰি না গাড়ী চলাই যায় সব মানুহ then তুমি হেৰি কৰিব লাগিব ট্ৰাকবিলাক চাব লাগিব সেইটো পেটাৰ্ণ নোটিছ কৰিব লাগিব it's all original destination survey so based on that you will get an idea of the traffic okay so once you get to know what is the traffic count so you either you get it from traffic survey or you can assume in my case I have assumed 3000 cbpt that means total 3000 commercial vehicles per day and construction period 2 years so a will be 3000 into 1 plus r to the power 2 then traffic growth rate minimum 5% in the absence of data as per ISC I am considering 6% minimum 5 so I am considering 6 this is also assumed mark ketaba dia thake but you generally need to figure out from ISC 108 then tomar national highway over to so tomar design life will be of 20 years okay vehicle damage factor যদি তোমাক দিয়া আছে distribution excel dot survey এখন হেৰি details table from there you can calculate okay from there you can calculate but you know if it is not if you are not conducting the survey generally collected from excel dot survey but if it is not collected then you can get it from IRC 1500 ke beshi hoy CBBD 3000 so and it is plain terrain Mumbai to Chennai will be plain terrain so data nai so ami hey table khonor pora jodi saw jot tomar ready dia asile pdf or calculator click koribo lage yeah here more than 1500 is plain terrain so you need to consider 5 pdf of 5 okay okay so 5 pdf is 5 lateral distribution factor okay this is what kind of road this fold and divided if it is divided then আমি directional traffic লম আৰু directional traffic লৈ ফালে যদি 2 lane আছে on both side আমি কিমান লৈছিলো 0.75 okay so all this d f a r all those things are now known to us okay so আমি p আৰু x assume কৰিছো so আমি a টো উলিয়ালো 1686 so তোমালোকে কৰা okay নকৰিলে অলপ কনফিউজ হ'বা এইটো কৰা এইখিনি can you please do So how much you are getting? Tell me the value. Tell me this. Without converting to MSA, tell me this. How much you are getting? Or you can check.
Sir, 84.9.
84.9. Very good. So 84.9 MSA. That means whatever the value you got, divided by 10 to the power 6, because it's million. Million mane kiman? 10 lakh. Right. So divided by 10 to the power 6. 84.9 MSA. Now what will be the next step? This is end design you got. So next step will be to decide what kind of pavement structure you are going to use. আমি দুটাই চাম, কিন্তু ফাৰ্ষ্ট আমি যেটো মোষ্ট কমন ইণ্ডিয়াত সেইটো চাম। মিনছ বিটুমিনাছ লেয়াৰ, দুটা লেয়াৰ বিটুমিনাছ, বিটুমিনাছ টেণ্ডাৰ বেড, টেণ্ডাৰ সাববেড, এণ্ড সইল সাববেড। Okay, so once you decide this, now you know where are the critical points. That means epsilon P here and epsilon B here, right? So in this case, we need to find out the whether, like basically in every design problem, let it be a building design or pavement design, we need to assume some thickness and we need to check whether that assumed thickness is sufficient or not. If it is not, we need to increase or we need to change the material properties. Okay, so in this case, we need to first start with something. So how will you start with? As I said, what is the CBR value given here? CBR value is not given. So what we can do, we can assume the CBR value as well. So assume the CBR of, generally you need to do CBR test and find out, but if it is not given, let's assume that it's 9%. Okay, so 9% or karone return plate 4 asile CBR 8% or karone mete acid 37 download kore tote swa, then plate 5 paba, that is for CBR of 9%. So 9% or karone amar traffic kiman aise 84.9 MSA, right? ইয়াতে 50 MSA লৈকে দিয়া আছে, 84 লৈকে দিয়াই নাই। 84 লৈকে তুমি নিজে উলিয়াব লাগিব, কিন্তু স্টার্ট ট্রায়াল 1 কৰিবৰ কাৰণে you can use this values. মানে surface course কিমান 40 mm, binder course 100 mm, base course 250 mm, sub base course 200 mm. Okay, and subgrade is half space, infinitely thick. Okay, so now you know all this information. Now you can proceed. Okay, before proceeding, you also need to assume some materials, because material assume nokorake how will you go tate toka lagibo no, especially for the surface courses key material use korisa. So generally if you see the table, tomar এইখন টেবুল জতিয়া আছে, okay, ইয়াতে tomar 50 কে বেছি হলে you can use bituminous concrete with modified binders. For surface course and for binder course, you can use dense bituminous macadam with VG40 bitumen. Alright, so you have assumed the materials, you know what kind of materials to be used as well. So তোমালোকে জাস্ট এখন বনাই লোৱা, এখন trial 1 40 mm, 100 mm, 250 mm, 200 mm and subgrade এখন বনাই লোৱা, কিন্তু মাজত এটা লাইন আছে। Okay, এখন ড্ৰ কৰা আৰু নেক্সট তুমি মেটেৰিয়েল প্ৰপাৰ্টি কেইটা লিখিবা ইয়াতে তোমাৰ লিখিয়ে দিছে WMM মানে ৱেট মিক্স মেকাডাম GSB মানে গ্ৰেনুলাৰ সাববেস মেটেৰিয়েল জাষ্ট তোমাৰ সাৰফেস কোৰ্সৰ মেটেৰিয়েল কেইটা ইউনিটটো লওঁ আমি গম পালো যে সাৰফেস কোৰ্সত তোমাৰ bituminous concrete with modified binder and binder কোৰ্সত তোমাৰ TBM with PG40 bitumen okay so you can now we can proceed to find out epsilon T and epsilon V based on this are the material properties and thickness okay so in our next class we will see how to find out this allowable ones and how to find out the ones that is like expected so in the next class we will use the software IIT PAVE and CanPAVE IIT PAVE বহুত দিগদাৰ ইনষ্টল কৰিব and একদম useless হয় so I don't recommend so CanPAVE software I will share with you guys okay so তোমালোক যোনকেইজন প্ৰেজেণ্ট আছা মোক জাষ্ট হোৱাটছএপত এটা মেছেজ দিবা okay and I will
Sir.
কোৱা sir
Sir, এটা কথা ক'ব আছিল মোৰ প্ৰজেক্টত মানে ফাইনেল ইয়াৰ প্ৰজেক্টত IIT PAVE টো দৰকাৰ আছিলে মানে আৰু মই কৰি আছিলো ইৰৰ দেখাই আছে বাৰ
সেইকাৰণে কৈছো
আপোনাক মানে মোৰ IIT PAVE ৰ পৰাই ওলাব দিছে স্যাৰ প্ৰজেক্টত ফ্লেক্সিবল পেভমেন্ট ডিজাইন বাই IIT PAVE
okay IIT PAVE মই দেখাব পাৰো বাট IIT PAVE ত তোমাৰ একো ডিটেইলছ বেছি দিবই নোৱাৰি মানে ইটস ভেৰি সিম্পল জাষ্ট তোমাৰ ৰান হোৱা নাই সেইটো এটা বেলেগ ইছ্যু হয় ৰান হ'বৰ কাৰণে ইউ নিড টু ইনষ্টল জাভা okay জাভাৰ কোনটো ভাৰ্চন লাগে that version you see and then you install okay you send me one message over WhatsApp মই তোমাক দেখাম কোনটো জাভাৰ ইনষ্টল কৰিব লাগে then it will run that's not an issue so কেতিয়াবা নহ'ব পাৰে তোমাৰ উইন্ডোজ 10 হয় নে উইন্ডোজ 11 হয়
উইন্ডোজ 11
উইন্ডোজ 11 ত প্ৰবলেম দেখাবতো নালাগিছিলে বাট ষ্টিল কেইটামান জাভাৰ আপডেট লাগে সেই আপডেট কেইটা কৰিলে হৈ যাব বাট আই ষ্টিল ৰিকমেণ্ড কেনপেভো তোমাৰ বহুত ইজি হয় কিন্তু IIT PAVEতকৈ বহুত বেছি ইফেক্টিভ মানে তো tomorrow can we have a class so that we can complete this design tomorrow Sunday আৰু only 2 or 3 students are interested it seems so if you are doing this project then definitely it will be useful for you and you can complete as soon as possible so is it okay tomorrow
okay sir
okay
sir
time let me tell দুটা বজাৰ পৰা 4টা বজালৈ ল okay 2 to 4 tomorrow আৰু মোক হোৱাটছএপত এটা মেছেজ দিবা I will share the link from where to download okay মই গ্ৰুপত এনেই দিব খোজা নাই আৰু ফ্ৰীতে চবে ডাউনলোড কৰক ফ্ৰীতে নলেজ দিওঁতে প্ৰব্লেম নাই বাট ক্লাছতো এটেণ্ড কৰা নাই ন কোনো আৰু গ্ৰুপত কিয় আছে তেন্তে জাষ্ট মেটেৰিয়েলছখিনি পাম আৰু ফ্ৰীতে লাগে সেইকাৰণেতো আছে ন চবৰ গ্ৰুপত মই সেইটো বিচৰা নাই মানে চব বস্তু লাইফৰ ইমান ফ্ৰীতে নাপায় একচুৱেলি তোমালোকে এই পেইনটো লৈ সেইটো বেলেগ কথা তুমি প্ৰজেক্ট কৰি আছা কাৰণে এটেণ্ড কৰিছা নাথাকিলে তুমি নকৰিলা হয় দেটছ ডিফাইন ইছ্যু বাট at least আহিছা so that's why I will share the link only to the people who message me over WhatsApp I will share the link and you can download okay ডাউনলোড কৰাৰ পিছত ইনষ্টল নিজে কৰি ল'বা হা বহুত ইজি হয় তাৰপিছত এনেকুৱা এটা এই ইমেজটো যেতিয়া দেখা পাবা ন কেনপেভৰ দেন ইউ উইল ন' ডেট your software has been installed okay IIT PAVE কৰাম মই কালি IIT PAVE কৰাব একোৱে নাই দুটা ভেলু দি ক্লিক কৰিলে অট'মেটিক হৈ যায় চব অ'কে চ' কেন পেভত অলপ মানে ইনপুট লাগে চ' এই ইনপুটখিনি মই ডিটেইলছত দেখাম ৰিজাল্ট ছেম আহে অ'কে কেন পেভ হওক আই টি পেভ হওক ৰিজাল্ট উইল বি ছেম ইভেন কেন পেভত তুমি অলপ বেছি একুৰেট ৰিজাল্ট পাবা অলৰাইট চ' okay let's meet tomorrow at 2 p.m. So who else are there in your group Vishal?
Sir, Rajdeep, then Jayashree,
Hmm.
Sonakshi আৰু Saina.
Okay so তোমাৰ ডিউটি নেকি আজি ক্লাছ কৰা
নহয় এনেকুৱা নহয় মই নৰ্মেলি যেতিয়া এই বাকী কেইদিন এক্সাম আছিল আৰু বেলেগ বেলেগ পঢ়িব আছিল কাৰণে ছাৰ কৰা নাছিলো দুদিন কৰা নাছিলো
নাই নাই
বাকীকেইদিন মই কৰিছো
বাকী কেইজনে কিয় কৰা নাই সেইটো মই সেনেকৈ বুজিছোঁ এইটোতো প্ৰজেক্টে হয়
মই গম নাপাওঁ ছাৰ এইটো
অ'কে সেইটো নহয় বাৰু গম পোৱা এনিৱে উইল মেট টুমৰো
ঠিক আছে ছাৰ